question 5 now, and before we start question 5, first of all write down this equation I'm going to use again and again. V1 equals V2 times C2 over C1. So let's run through what these these values mean. So V1 is the volume of the stock solution we're going to make up to our desired volume. Okay, that's what we're trying to find out. V2 is the volume of our desired solution. Okay, how much we want. C1 is the concentration of our stock solution, and C2 is the concentration of our desired solution. Let's look at this question now. How much of a 2.5 molar salt solution would you need to have a final working concentration of 200 micromoles in a 1 milliliter assay? So what we're trying to do here is work out V1. Okay, V1 is what we're wanting out. Okay, what volume of this 2.5 molar sodium chloride solution are we going to pipette into so that gives us 200 micromoles in a 1 mil assay? So let's go through and interrogate it. So V1 is what we're trying to find. Okay, and V2 is the volume of the desired solution. So V2 is this. That's our desired solution. Okay, so we can just pop this straight in here. That's 1 milliliter. Okay, and it's a 2.5 molar sodium chloride solution. Okay, that's the concentration of our stock solution. That's C1. Okay, so that can go in as C1. 2.5 molar, and it's 200 micromoles, and that's the concentration of our desired solution. That's C2. Okay, concentration of our desired solution. So let's pop that in here, 200 micromoles. And when I'm looking at this, it looks problematic to me because we've got micromoles and we've got moles in the one calculation. So it's best if, well, it's essential that they're all at the same in the same units. So 200 micromoles and 2.5 moles. There's quite a big difference between these. So I'm going to sort of choose a compromise of working in not in micromoles but in millimoles. Okay, so there's 1 milliliter times 0.2 millimoles. Okay, 200 micromoles is 0.2 millimoles, and 2.5 moles is the same as 2,500 millimoles. Okay, so automatically we've got, you can see that we're now all working on this with the same units. Okay, so let's just do this wee sum, and when we run through this sum, so it's 1 times 0.2 divided by 2,500, we get this 1, 2, yeah, that's 4, 8. Okay, and remember we're calculating a volume here, so we're working in milliliters, so this answer is also going to be in milliliters. So there we go, we've got 0.00008 milliliters. That's a very, very small number. So we need to change this into microliters now. Okay, just to give us an idea of it's a feasible number for us to pipette. Okay, because that looks like a really small number. So if we change that into microliters, we see it's 0.08 microliters. Now, your experience of working with Gilsons will tell you that that's too small. So we're not going to be able to pipette out 0.08 microliters into an Eppendorf and then make it up to 1 milliliter. Okay, that's not going to work. So we're going to have to choose a different way of working here, because that's far too small a concentration to work with. So what we're going to do is we're going to have to make an intermediate stock solution that's a little bit more dilute than our initial stock solution. Our initial stock solution was 2,500 millimoles. We're going to have to go a little bit more dilute. So why don't we say we're going to make up a solution that's 5 milliliters of 100 millimoles. Okay, that's our first. We're going to make up a new, it's going to be a two-stage calculation actually. So stage one is we're going to make up 5 mils of 100 millimoles. Okay, and then stage two is going to be where we try and where we answer the question really, and that is stage two is we're going to have a 200 in 1 mil. Okay, so we've got two stages to this now. So let's work out stage one. We're just going to use the same equation as before. So V1 equals V2 times C2 times C1. So V2 is 5 mils. Okay, so that's going to be 5 mils. C2 is our concentration. That's going to be 100. Okay, and our initial concentration, what we're starting off with, is 2,500 millimoles. Okay, and when we do all of that, we do that calculation, 5 mil, okay, 5 times, that's 500 divided by that, gives us 0.2 mils of original stock solution into, or made up to, 5 mils. Okay, so that's what we're going to do to begin with. Okay. Right, stage two. Stage two is when we're going to take this sum, okay, and then we're going to recalculate it. Okay, so stage two, we're just going to start off with the same thing again. V1 equals V2 times C over C1. Okay, now we want our final volume here is going to be 1 milliliter. We get that from this. We get that from the question. Okay, C2 is the concentration of our desired solution. The concentration of our desired solution is 200 200 microliters. 200 microliters is 0.2 millimole, millimoles, sorry. And C1 is the concentration of our stock solution. Well, this is our new stock solution. We thought we'd make our stock solutions 100 millimoles, so that's going to be 100 millimoles there. So we run through that. 0.2 divided by 100 is going to give us 0.002002 milliliters is the same as, can we work with 2 microliters? Yeah, sorry, it's off the bottom here. Our Gilsons can work to really tricky, really took me 8 minutes to explain that.